Good morning, everyone. I am back. Today we are going to be talking about 10.4 compound events, and I'm going to leave part of 10.4 because it kind of goes right into 10.5 and I don't want it to confuse you. So by the end of today, you guys should be able to create tree diagrams and you should be able to apply the fundamental counting principle. Okay, so if I am making a sandwich and can choose from white or wheat bread, I can also choose between ham, salami, or turkey. It says draw a tree diagram and give the sample space. How many sandwiches can be made? Sample space means, sample space means list the outcomes. That means to list the outcomes. Okay, how many different combinations will I be able to have? Okay, so tree diagram, what I'm going to do is I'm going to list the first things that I have to choose from. I can choose white bread, or I can choose wheat bread. Okay, well, let's just say that I choose white bread. Now I've got to choose what kind of meat I want on my sandwich. Okay, so I could go white with ham. I can go white bread with salami, and I could also go white bread with turkey. But let's say I don't want white bread, I want wheat bread. I can go wheat with ham, I could go wheat with salami, and I can also go wheat with turkey. This is what we call a tree diagram. It lists the outcomes that I can have. So the sample space, I'm going to write these out. I could do white with ham. So I'm going to abbreviate it. White, ham, there's one outcome. I could do white with salami. And I could do white with turkey. I could also do wheat with ham. I could do wheat with salami. And I could do wheat with turkey. Okay, this is my sample space. How many outcomes are there? How many outcomes do you see? Well, I see 6 outcomes. Okay, now let's talk about this for a second. And if I didn't want to have to draw that tree diagram, how do you think that I could come up with 6 outcomes without having to draw all that out? Well, let's look at how many choices of bread did I have? I had 2 choices of bread. How many choices of lunch meat did I have? I had 3. What do you think you could do to those 2 to get 6? Yep, you're probably right. You're going to multiply them together. That is what we call the fundamental counting principle, and it says to find the number of possible outcomes, you take m times m, which means multiply the different events and the outcomes. M event has m ways of occurring, n event has n ways of occurring. Okay, so compound event is an event that consists of 2 or more events. So this could also be 3 events. Let's say we had 3 events taking place for the one above it. If I had 2 lunch meats, 2 breads, 3 lunch meats, and let's say I could choose mayonnaise or mustard. That would be 3 events. Okay, so I would take m times n times p. P would be the mayonnaise or mustard. So let's look at number 1. It says, I roll a cube and flip a coin. How many outcomes are there? Well, let's look at a number cube. How many outcomes are on a number cube? There are 6. How many outcomes are on a coin? There are 2. So to figure out how many possible outcomes there are, we multiply them together, there would be 12 outcomes. Okay, this is 2 events. This is the first one, that's the second one. Okay? Look at example 2. I have 3 shirts, 4 pair of shorts, and 2 pair of shoes. How many outfits can I make? Okay, there's one event here, there's another one here, and another one here. How many shirts do I have to choose from? 3. How many pairs of shorts? 4. How many pairs of shoes? 2. How many different outcomes could I have? Well, I just multiply them together. I can do 3 times 4, which is 12, times 2 is 24. I have 24 different outfits I can make. Okay? Number 3, I can choose from small, medium, or large, or extra large, and can select Coke, Diet Coke, or Sprite. How many outcomes do I have? Well, how many events are there? There's the size, and there's the drink selection, so that's 2. Well, I have 4 sizes to choose from, and 3 drinks, so there are 12 different outcomes. Okay? And think about this too, you guys. If you ever have a debit card, I'm sure some people know of others that have debit cards. This is example 4. And we talked about this in school. If I have a 4-digit PIN number, okay, I want to know how many outcomes are there. Well, what I would do is I put a blank. Here's for the first one, here's for the second number, here's for the third number, and here's for the fourth number. If I have to have a 4-digit PIN, how many digits are there? Well, let's talk about this. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are all called digits. How many are there? We'll count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. There are 10 digits. You guys, if you hold up your fingers, fingers are called digits. How many fingers do you have? You have 10, so there are 10 digits. Okay, so if you could pick any number in any place, how many different outcomes will there be? Well, how many do I have to choose from the first one? 10. The second one? 10. Third one? 10. The fourth one? 10. How many different outcomes could I have? Well, 10 times 10 times 10. That is a 1 with 4 zeros, right? 1, 2, 3, 4. That's 1, 2, 3, 4. So I have 10,000 outcomes. What's the probability? If I said to you, what's the probability that somebody guesses my PIN number right on the first time? I would have to say it's 1 out of 10,000. Okay, and we'll get into that more in the next lesson. Let's just practice some. It says Marcus spins the spinner at the right and flips a dime at the same time. What are the possible outcomes? How many outcomes are in the sample space? How many events are taking place? Well, he's spinning the spinner and he's flipping a dime. So I'm going to make my tree diagram. He could spin a 1, a 2, or a 3. Now he can get a 1 with a heads. He can get a 1 with a tails. So in my sample space, I have a 1 heads, 1 tails. He could get a 2 with a heads, 2 with a tails. That would be 2 heads, 2 tails. Could get a 3 with a heads, 3 with a tails. So that would be 3 heads, 3 tails. Okay, so how many different outcomes are there? Count them up. There's 6 outcomes. Okay. I'm going to not do number 2. If we look at number 3, it says Susan and Ryan are playing a game that involves spinning the spinner at the right and flipping a penny. How many outcomes are possible? We do not have to do the tree diagram. How many events are taking place? They're spinning the spinner and flipping a penny. So there's 2 events happening. So first one with the spinner. How many numbers are on the spinner? How many spaces are there? There are 8. Times how many on the penny? 2 sides. So there's 16 outcomes. Look at 4. An Italian restaurant offers small, medium, and large calzones. The choices of fillings are cheese, sausage, spinach, or vegetable. How many different calzones can you order? Well, there's 2 events, right? A calzone and its filling. There are 4 sizes times 4 fillings, and you get 16 outcomes. right, let's look down at number 6. Rashid has tan pants, black pants, gray pants, and blue pants. He has a brown sweater and a white sweater. How many different ways can he wear a sweater and the pants together? Well, that's 2 events again. Okay, well, let's look at the first one. How many different pants does he have? It's pants and sweaters. 1, 2, or 3, or 4. So we have 4 different colors of pants. And what about sweaters? He has a brown one or a white one. So multiply by 2 there. He has 8 different outfits. Okay, pretty simple. Hope you have a great day. And one last thing. Wanted to ask you, what did the acorn say when it grew up? What did the acorn say when it grew up? Gee, I'm a tree. Gee, I'm a tree. Geometry and gee, I'm a tree. All right, you guys have a good day.